All right, everyone, get ready because today we are diving deep into something truly mind-bending.
Anti-gravity.
You got it.
Yeah.
You've sent over a whole bunch of stuff.
A lot of material.
A scientific essay, some patent application materials, even a paper trying to connect this new model to Einstein's relativity.
Wild stuff.
It is a lot to unpack, but
It is.
the core idea here, this Fibonacci-scaled SMF RVS framework, claims it can not only achieve anti-gravity, but also create artificial gravity inside a spacecraft.
Which is pretty remarkable.
Yeah, it is.
Pretty amazing.
So we're going to get into all that good stuff.
We're going to try.
Yeah.
What I find really fascinating about all of this is that this model really flips the script
Okay.
on how we think about gravity.
Yeah.
Instead of the familiar pull we experience every day, it describes gravity as a push.
Okay, wait, a push.
A push.
That's not how any science class I ever took explained it.
I know, right?
Yeah.
It's a total departure from, your classic Newtonian and even Einsteinian view.
Yeah.
I mean, we're just so used to thinking of gravity as this invisible force that's pulling everything towards the center of the Earth, right?
Right.
But this framework is saying, no. It's the vacuum of space itself,
Okay.
pushing things together.
So instead of the Earth pulling me down,
Right.
space is pushing me towards it.
Sort of, yeah.
I'm having a little trouble wrapping my head around that.
It is mind-bending.
It is.
I'll totally admit that.
Yeah.
But this push, according to the essay, is all about the interplay of two things.
Okay.
The subtle magnetic field,
Okay.
or SMF,
Right.
and the relative vacuum of space,
Yeah.
the RVS.
Those are some pretty hefty acronyms.
They are.
Can you break those down for me?
Yeah, of course.
A little bit further? What exactly are SMFs and RVS?
Sure. So imagine like a type of magnetic field
Okay.
that it permeates the entire universe.
Okay.
But it's much, much weaker than the magnetic fields that we're used to, like,
Right.
the ones that we use in our everyday technology.
Yeah.
So that's the SMF. Okay. And it interacts with the RVS,
Right.
which is essentially the vacuum of space.
Okay.
Now, here's the kicker.
Okay.
The RVS isn't actually empty.
What?
It has an inherent outward pressure.
So it's like this invisible pressure
Yes.
that's constantly trying to push everything apart.
Yeah, that's a good way to think about it.
Okay.
It's like this constant outward force
Wow.
permeating everything.
Okay.
And it's the SMF
Okay.
that modulates that pressure
Uh-huh.
in a way that creates the force we perceive as gravity.
Okay, so how does that actually work? How does the SMF shape this vacuum pressure to make things fall down?
So think of it like this. Every object,
Okay.
including the Earth,
Yeah.
has its own SMF wave, right?
Okay.
So this wave interacts with the RVS.
Yeah.
And what that does is it creates variations in the vacuum pressure.
Okay.
And these variations, get this, are what push objects towards each other.
So it's not that the Earth is pulling me down,
Yo.
but rather that the vacuum pressure around me is lower than the vacuum pressure further away from the Earth.
Right.
And that difference is pushing me towards the ground.
Yes, exactly.
Good.
That's a really good way to put it.
Okay.
And what the essay claims is that by understanding and manipulating these SMF waves,
Yeah.
we could potentially control gravity itself.
All right, that's where you need to slow down for me a little bit.
Okay. Right.
How exactly
Yeah.
do they propose to control something as fundamental as gravity?
That is the big question, isn't it?
It is.
So this is where this concept of Fibonacci scaling comes in.
Fibonacci scaling.
Fibonacci scaling.
Okay.
So think about it like this. Imagine like a sound engineer with a super advanced equalizer,
Okay.
not just controlling bass and treble, but also subfrequencies and harmonics that we
Right.
can't even hear.
Yeah.
That's kind of what Fibonacci scaling does with gravity.
So Fibonacci scaling is like fine-tuning gravity
Yes.
across multiple,
Yeah, think about it.
even invisible levels.
It could be across multiple dimensions even.
Oh, wow. That's some serious cosmic control.
It is.
But how does this actually lead to anti-gravity?
So the idea is that by precisely manipulating the SMF,
Okay.
you can actually cancel out the vacuum pressure push in a specific area.
Okay.
Imagine you can create a zone
Yeah.
where the vacuum pressure is essentially neutralized,
Right.
so there's no force pushing you down anymore.
So you're saying if we crack this, we could literally build a Star Trek-style spaceship.
That's the dream, right?
Yeah.
One that just lifts off the ground effortlessly.
It's off.
Yeah, it's like
Without any-
Brooks.
Without any fire, without any
Without any rockets.
rockets.
Yeah.
Wow.
But it gets even wilder.
Okay.
This Framework claims we could also use SMF's technology to create artificial gravity inside a spacecraft,
Okay.
even if there's no gravity outside.
Wait, hold on.
Yeah.
How is that even possible? If you're canceling out gravity
Right?
to make the spaceship float,
Yeah.
wouldn't everyone inside just be floating around too?
That's the ingenious part, right?
Mm.
So the source describes a device
Okay.
that would not only generate an opposite SMF wave
Mm-hmm.
to counteract Earth's gravity outside, but also create a separate, contained SMF wave inside the craft to mimic Earth's gravity.
I'm trying to picture this.
Yeah.
Are you saying this device would act like a giant magnet or
No, not a magnet.
something completely different?
It's something completely different.
Oh, okay.
They call it an exotic field generator in the patent application.
Exotic field generator.
Yeah. And they even have a name for the structures that they would use to direct the SMF waves.
Okay.
Metamaterial waveguides.
Metamaterial waveguides.
Yeah, it's pretty sci-fi.
This is starting to sound like
Yeah.
something straight out of a sci-fi movie.
A little bit.
So how would this all work in practice? How would they actually make a spaceship levitate?
Okay, so imagine a spacecraft with an array of these exotic field generators built into its hull, right? These generators would create an SMF wave that's precisely tuned to cancel out the Earth's SMF wave
Right.
in a specific area around the craft.
So they're basically creating a bubble
Yeah, think of it like a bubble.
of zero gravity around the spaceship.
That's a great analogy.
Okay.
And within that bubble, the craft would be free from the push of Earth's gravity and could lift off the ground effortlessly.
Okay.
It would be pretty amazing to see, I imagine.
Okay, I think I'm starting to get this.
Okay, good.
But if they're canceling out gravity outside,
Right.
how do they keep the astronauts from floating around inside?
So that's where the metamaterial waveguides come in, right?
All right.
So they're embedded within the craft's hull,
Okay.
and they act like a network of channels
Okay.
guiding the SMF waves.
Right.
And so they would direct a specific SMF wave inside the craft to create an artificial gravitational field,
Okay.
which would keep the astronauts, firmly on the floor.
So it's like they're creating a zone of anti-gravity outside
Yeah.
and normal gravity inside. It's exactly.
All by manipulating these
Yeah.
SMF waves.
That's the idea.
That's absolutely incredible.
It is.
But wouldn't a force that powerful be inherently unstable?
That's a great question.
How do they address that in the source material?
They acknowledge that it would require a really complex control system
Okay.
to constantly monitor and adjust the SMF fields.
Right.
I mean, imagine
Yeah.
if, there's a little fluctuation, it could be pretty catastrophic. But
Yeah.
they even mention a chronoloop stabilizer.
A chronoloop stabilizer.
Yeah.
What in the world is that?
It does sound like something out of,
It sounds like something out of Doctor Who.
Doctor Who or something.
Right.
Yeah, it does a little bit.
Yep.
But what they're suggesting
Yeah.
is that manipulating space-time, especially on this scale,
Right.
could potentially create some, unintended consequences.
Unintended consequences like what?
Well, like time paradoxes.
Time paradoxes.
Yeah.
Okay, so we're not just talking about building a spaceship.
We're talking about potentially opening up wormholes
We're talking about
or even traveling through time.
possibly.
Oh, my.
Yeah, it gets pretty heavy.
This is
It gets pretty far out there.
way more complicated than I initially thought.
It does. It does.
Okay.
But that's what makes this deep dive so fascinating.
Yeah.
I mean, we're exploring the frontiers of physics.
Right? Yeah.
Who knows what incredible discoveries await us?
Okay. I need a moment to process all of this.
Take your time.
We've gone from apples falling to the ground to time travel in just a few minutes.
It's a lot to take in.
It is a lot.
Yeah.
I think we've covered a lot of ground already, from the basics of the SMF RVS framework to the mind-blowing concept of a chronoloop stabilizer.
It's a lot.
I don't know about you, but my brain is already working overtime.
Yeah, mine too.
Okay.
But this journey is just beginning, though.
Oh, all right.
We've only scratched the surface of this incredible new model of gravity.
All right, everyone listening, get ready, because in part 2, we're going to dive even deeper into the mind-bending possibilities of anti-gravity and the Fibonacci-scaled SMF RVS framework.
Gonna be good.
Stay tuned.
Stay with us.
All right.
Okay, welcome back to our deep dive into the world of anti-gravity. I hope everyone's had a chance to, kind of process all that stuff from the last segment, because things are about to get even more interesting.
I'm still trying to wrap my head around the concept of gravity as a push.
It is a pretty radical idea,
It is.
isn't it?
It's amazing to think that the vacuum of space,
Yeah.
something we usually think of as empty,
Yeah.
could actually be the source of this force
This force.
that shapes our entire universe.
It's crazy to think about.
Yeah.
You know?
It is.
And yet, this SMF-RVS framework,
Right.
as out there as it sounds,
Right.
really has the potential to revolutionize our understanding of gravity
Totally.
and open up these possibilities we could only dream of before.
That's what I'm really excited to dig into.
Yeah, me too.
In the last part, we talked about, like, the theoretical science
That's
behind this new model.
Right.
But now I want to let our imaginations run wild.
Okay, let's do it.
If we could actually control gravity,
Yeah.
what would that mean
What would that mean?
for humanity? Where do we even begin?
Well, I mean, I think,
Uh,
we'd have to start with, the most obvious application,
Okay.
space travel.
Okay.
Right. Imagine a world where
Yeah.
we no longer needed those, like
Yeah.
gigantic, expensive rockets
Right.
to escape Earth's gravity.
Right.
Instead, we have spacecraft equipped with these exotic field generators.
Okay.
And they just, gracefully lift off the ground,
Yeah.
gliding into orbit
Right.
as effortlessly as a bird taking flight.
It would be like something out of a science fiction movie.
It really would.
Yeah.
It would be incredible.
No more fiery launches.
No more explosions.
No more massive fuel consumption.
Right.
Just a smooth, silent descent into the cosmos.
Yeah, think about that.
That would change everything.
It would. It would totally change everything.
And it's not just about exploring space.
Right.
Think about what it would mean
Yeah.
for transportation here on Earth.
Oh my gosh, totally.
Right. We could have floating vehicles instead of cars,
Instead of cars.
soaring above traffic jams and eliminating the need for roads altogether.
Yeah, like our cities would be completely transformed.
They would be.
Imagine like sleek, silent vehicles gliding through the air, navigating three-dimensional space.
Right.
Instead of being confined to these like two-dimensional streets,
Yeah.
it would be a completely different way of experiencing urban life.
It all sounds amazing.
Right.
But isn't this starting to sound more like science fiction
Well,
than science?
what about-
Where's the line? I mean, if we could build floating cars,
yeah,
what's to stop us from creating entire levitating cities?
I know, right?
Buildings that could just rise above the ground,
That's what I'm saying.
escaping natural disasters, or maybe even moving to different locations.
That's a fascinating thought.
It is.
And, it is something that the essay touches upon.
Okay.
They talk about using SMF technology to protect buildings during earthquakes.
Okay.
So, like, creating structures
Yeah.
that could gently lift off their foundations during a seismic event,
Right?
minimizing damage,
Right.
potentially saving countless lives.
Wow.
It's a mind-boggling concept.
It is.
But if we could control gravity,
Right.
I mean,
Right.
who's to say what's impossible?
It's like the possibilities
It's endless.
are literally endless.
Right.
We could revolutionize architecture, urban planning,
Yeah,
even disaster relief.
I know.
But before we get too carried away
Yeah.
with all of this, I think we need to step back
Okay.
and address the elephant in the room.
Okay. What's that?
Is this technology
Right.
even remotely feasible?
That's a great question.
Can we really build these exotic field generators
Right.
and metamaterial waveguides?
That is the million-dollar question.
Yeah, it is.
Right. I mean, the scientific principles behind the SMF-RVS framework, they are certainly intriguing.
Okay.
But as we discussed earlier,
Yeah.
the engineering challenges are immense.
Right.
I mean, we're talking about generating and controlling magnetic fields on a scale that dwarfs anything
Right.
that we can currently achieve.
Right.
It would require, breakthroughs
Yeah.
in material science, energy generation, and really our understanding of the very fabric of reality.
So it's not just a matter of building a bigger magnet.
No.
We're talking about a fundamental leap forward in
It's
our
an-
understanding of physics.
a whole new paradigm,
Oh, wow.
It really is a monumental task,
It is.
to say the least.
Right.
But, history has shown us time and time again that what seems impossible in one era can become reality in the next.
Right.
Okay,
Yeah.
who could have imagined a century ago
Right.
that we would have smartphones,
Right.
the internet,
Internet.
or spacecraft exploring the outer reaches of our solar system?
Right. You're right. Technology has a way of surprising us.
It does.
But even if we could somehow overcome
Right.
these technical hurdles, wouldn't there be some serious safety concerns? I mean,
Definitely.
we're
So-
talking about manipulating one of the most fundamental forces in the universe.
One of the most fundamental...
What happens if something goes wrong?
Yeah, I mean, safety would absolutely be paramount.
Right.
Imagine like a floating vehicle malfunctioning mid-flight,
Right.
or the gravitational field inside a building suddenly fluctuating. The consequences could be catastrophic.
We're not just talking about a car breaking down.
No.
We're talking about potential disaster on a massive scale.
Exactly.
And even if we could ensure the safety of this technology, what about the ethical implications?
Oh, that's another huge one.
Who would have access to it?
Yeah.
How would we prevent its misuse?
You bring up a really crucial point,
Yeah.
I mean, it's not enough to simply develop a powerful technology. Right? We need to consider its impact on society, on the environment, and the very fabric of our existence.
Yeah.
So the ethical considerations are just as important, if not more so, than the technical challenges.
It's like when nuclear fission was discovered.
Yes.
Right.
That's a great parallel.
Incredible potential for energy and advancement.
Right.
But also a huge responsibility.
A huge responsibility.
To handle it with extreme care.
Yeah, exactly.
So where do we go from here?
That's a good question.
What are the next steps in exploring this mind-blowing concept of anti-gravity?
Well, I mean, the first step is further research.
Right. Okay.
I mean, we need to rigorously test the scientific principles behind this SMF-RVS framework.
Okay.
And determine whether it actually holds up under scrutiny.
Right.
We need more experiments, more data, more, brilliant minds working together to really unravel this cosmic puzzle.
It sounds like a long and challenging journey.
It does.
But with potentially incredible rewards.
Absolutely.
Right.
It's a journey that could rewrite our understanding of the universe.
Totally.
And unlock these possibilities.
Right.
Beyond our wildest imaginations.
Welcome back to the final part of our deep dive into anti-gravity. We've explored this mind-blowing SMF-RVS framework, a model that dares to reimagine gravity.
Oh, right.
Not as a pull, but as a push.
It's crazy.
Now we're facing the ultimate challenge. How does this new model, with its exotic field generators and talk of canceling out gravity, reconcile with everything we thought we knew from Einstein?
Yeah, it's a big question.
It is.
And honestly, one that has physicists scratching their heads.
Yeah.
But, the paper that you sent? Right.
It tries to build a bridge between this SMF-RVS framework and Einstein's general relativity.
Okay.
At least mathematically.
Okay, I'm all ears. How can a model that talks about controlling gravity with technology possibly mesh with Einstein's view of gravity as warped space-time?
Yeah, they do seem...
Those seem worlds apart.
They do.
Yeah.
But here's the thing.
Okay.
This new model aims to reproduce the effects of gravity as predicted by Einstein in normal conditions.
Okay.
Even if it uses a completely different mechanism to get there.
So it's like they're saying, sure, Einstein's got it right about how gravity behaves in our everyday world.
Right, exactly.
But here's a different explanation for why it behaves that way.
Yeah, that's a great way to put it.
Okay.
They use the concept of an effective metric.
Okay.
So, like in Einstein's theory,
Yeah.
gravity is all about the curvature of space-time.
Right.
Right, the way mass and energy warp the fabric of the universe,
Yeah.
This new model is saying that...
The SMF and the RVS.
Right.
Along with that Fibonacci scaling that we discussed.
Right.
They create a kind of illusion.
An illusion.
Curved space-time, yeah.
So space-time isn't actually warped in this model.
That's the implication, yeah.
Okay.
Though I'll admit, it gets pretty complex.
Yeah.
The math in this paper claims
Yeah.
that the interplay of SMF and RVS produces the same observable effects as curved space-time.
Okay.
Even if the underlying cause is different. It's like, imagine you see a magician, pull a rabbit out of a hat.
Right.
You see the rabbit appear.
Right.
But the actual mechanism is hidden.
Right.
And they're kind of saying that that's what's happening here
Okay.
with gravity.
That makes my brain hurt a little.
It's a lot.
But I'm starting to see how they're trying to connect these two seemingly opposed ideas. But you mentioned earlier that things get really interesting in extreme conditions.
Yeah, like near a black hole. Is that where this new model breaks away from Einstein's predictions?
Exactly. So like in those extreme situations, like near a black hole where gravity is incredibly strong,
Right.
general relativity requires something called negative energy density
Negative energy gets...
to create those extreme warps in space-time.
I'm lost already.
Yeah, it's a pretty wild concept.
What in the world is that?
Yeah, so imagine
Oh, yeah.
like a kind of anti-gravity energy that actually pushes space-time apart
Okay.
instead of pulling it together.
Wow.
It's theoretical,
Okay.
but it's something that is needed in general relativity to explain those extreme gravitational scenarios.
Okay, so how does this new model handle those situations?
Yeah, so that's where it gets even more interesting.
Does it need this negative energy too?
So they're saying no.
Okay.
You don't need this exotic negative energy. Instead, what they're proposing
Yeah.
is that those extreme gravity scenarios are created by regions of negative vacuum,
Okay.
where the vacuum pressure
Yeah.
is even stronger than usual. So they're replacing this mysterious negative energy with a really, really strong vacuum pressure.
Essentially, yes.
Does that actually make things simpler?
I don't know if it's simpler,
Right.
but it's definitely a different approach.
Okay.
And it leads to some, like, pretty startling implications.
Okay, like what?
So, if this model is correct,
Yeah.
those regions of negative vacuum could potentially create effects
Yeah.
that are very difficult to explain with general relativity.
Effects like what? Don't leave me hanging.
Okay. Okay, so we're talking about things like wormholes,
Wormholes.
those theoretical shortcuts through space-time.
Right.
And maybe even the possibility of time travel,
Time travel.
concepts that are
Okay.
both fascinating and terrifying.
This just keeps getting more and more like a science fiction movie.
I know, it's pretty wild.
But if this negative vacuum is so powerful,
Yeah.
wouldn't it be incredibly unstable? Wouldn't it just like rip the universe apart?
I mean, that is a valid concern.
Yeah.
And the authors of the paper, they do acknowledge that.
Okay.
They propose that something called the Fibonacci stabilizer
Yeah.
would prevent those, catastrophic instabilities.
The Fibonacci stabilizer, another sci-fi term. So they're saying this stabilizer keeps the universe from imploding
Essentially, yes.
due to this intense vacuum pressure.
Yes, they are.
But how does it actually work? Magic.
It's not magic, but it's pretty close.
Yeah.
So remember we were talking about Fibonacci scaling
Yeah.
and how it operates across multiple fractal dimensions?
Right.
So the idea is that this scaling factor acts like, a cosmic pressure valve,
Oh, wow.
keeping the negative vacuum in check.
So it's like nature has a built-in safety mechanism to prevent these regions of extreme gravity from getting out of control.
Yeah, that's what they're proposing, though. It's highly theoretical.
Right.
And, of course, we can't forget about the chrono-loop stabilizer that we talked about earlier.
Right, of course.
I mean, in this model, it's not just about preventing, the universe from collapsing.
Right.
It's also about preventing those pesky time paradoxes that might arise if we start, messing around with space-time.
Time paradoxes, cosmic pressure valves. I feel like I'm taking a crash course in theoretical physics.
Yeah, it is a lot, I know.
But, all this talk about negative vacuum and wormholes is pretty exciting.
Yeah.
Is there any actual evidence to support this new model, or is it all just mathematical speculation?
Yeah, that's the crucial next step,
Okay.
right? For this model, for this SMF RVS framework to gain any kind of traction,
Right.
it needs to make testable predictions.
Oh,
Not just offer, like, a different explanation
right.
for what we already know.
So it has to play by the existing rules of gravity
It does.
before it can try to rewrite them.
It has to pass, they call it the Einstein test.
The Einstein test.
First, meaning it needs to perfectly reproduce all the predictions of general relativity
Okay.
that have been confirmed by, experiments and observations over the years.
But then it needs to go further
It does.
and make unique predictions
Yes.
that could distinguish it from general relativity.
Exactly.
Okay.
That's where things like the negative vacuum and its effects on space-time become really, really crucial.
So we're looking for evidence of those wormholes and time warps. Sign me up for that research team.
I mean, those might be a little out of reach for now,
Yeah.
but there could be, other, like, more subtle effects
Right.
that we could detect, with advanced telescopes or experiments.
Okay.
Like, maybe we'll find strange gravitational anomalies,
Yeah.
near massive objects, or,
Yeah.
perhaps tiny fluctuations in the fabric of space-time itself. I mean,
Right.
the search is on,
Wow, this has been quite a journey.
It has.
We've gone from rethinking gravity as a push
I know.
to contemplating the possibility of wormholes and time travel. It's mind-blowing to think that we might be on the verge of a whole new understanding of the universe and our place within it.
Yeah, it's a pretty amazing time to be alive,
It is. It is.
And I think that's the beauty of science, right?
Yeah.
It's this constant process of exploration, questioning, and discovery.
right.
And we may never have all the answers.
Yeah.
But the pursuit of knowledge that's what drives us forward,
Totally.
pushing the boundaries of what we think is possible.
I couldn't have said it better myself. So to everyone listening,
Yeah.
keep your minds open, keep asking those big questions,
Keep wondering.
and never stop exploring the wonders of the universe. Who knows what incredible discoveries await us just around the corner? Thank you for joining us on this deep dive into the fascinating and sometimes baffling world of anti-gravity. Until next time.